Welcome, class. Thank you for joining me again to continue Chapter 9. So we are diving into 9.2, talking about arithmetic sequences. Now, this is something you should have seen back in the 8th grade, all right? So arithmetic sequences. There are a sequence of numbers where the difference between consecutive terms is constant. This is called the common difference. So what are we talking about? Well, we're talking about starting with our initial value, that initial condition, and then to get to the next term, you add d. To get to the term after that, you add another d. To get to the next term, you add d again. So you're adding the same number every single time. That is how you're generating this sequence. So let's take a look. To determine if something is arithmetic, all you have to do is see, are you adding the same thing over and over and over again? So let's see. To get from 3 to 6, you're adding 3. To get to 3, or from 6 to 9, you're adding 3. 9 to 12, you're adding 3. 12 to 15, you're adding 3. So, yes, this one is arithmetic. And what is a common difference? Well, here the common difference is 3. So let's check our next one. Going from 1 to 4. All right, we're adding 3. 4 to 9. Oh, uh-oh. This time we're adding 5. If you keep going here, we're adding 7. This time we're adding 8. So, oh, sorry, not 8, adding 9. So this one is not arithmetic. You're not adding the same thing over and over and over again. Okay. How about the next one? Let's take a look at that. So here we're adding 2. Oh, uh-oh. Here we're adding 4, adding 8. Well, that doesn't look promising either. We're not adding the same thing over and over and over again. So this one isn't arithmetic either. So it's pretty easy to determine if something is or is not. All you have to do is check, am I adding the same thing over and over again? If I am, perfect, arithmetic. If I'm not, well, then you're going to have to say no. Now, obviously, in this process, what's really important to us is being able to represent these things. So we have specific rules to look at for those recursive and explicit definitions. That's why we spent yesterday investigating how to write those, because now the cool thing is if we know we're dealing with something arithmetic, well, your rule is always the same. So for recursive formulas, again, you start with that initial condition, the A1 being just whatever A1 is, and then you set it up. A to the n is a to the n minus 1 plus that common difference. All you're doing between terms is adding that d. Okay? So, for example, let's say I wanted to write a recursive definition for this first one that we identified, yes. Well, I set up that initial condition. So A1 would equal 3. And then I will set up recursively that every time I'm taking the previous term and I'm just adding 3 because of those 3's right there. Adding that common difference. So really not too difficult, right? So for the explicit formula looks like this. So every term you take that a to that first term, that a to the first term, and you are adding on n minus 1 d's. And again, n representing how many terms there are. So again, that n is kind of your variable. The n is what's going to stay. You plug in A1, you plug in D, and then you clean it up. Okay? So let's see what this looks like in practice with a couple examples. So usually when we create those formulas, usually we're creating that explicit formula because we're looking for a future term. So if we're trying to find the nth term of a given arithmetic sequence, first you identify A1 and D, okay? You need your first term and that common difference. You want to use those values to make an explicit formula, okay? More often than not, we're talking about explicit formulas. And then we want to plug n in to get the nth term. All right, so taking a look at our first example, what is the 100th term of an arithmetic sequence that begins 6, 11, so on and so forth? So my first term is 6. I also need that D. So what am I adding to go from term to term? Well, I'm adding 5. So let's take a look at our formula now, shall we? So we have to set this up. Here's our formula. So let's plug it in. A1 is 6 plus n minus 1 times D. Now again, let's clean it up a little bit. All right, so we're going to have 6 plus, distribute that 5. So 5n minus 5. So our equation is going to be 5n plus 1. Okay, so there is our explicit formula. Now, you may notice your formula looks very familiar. That is also the formula of a line. Arithmetic sequences, if you were to plot them as points, they would form a perfect line. All right, so we have our explicit formula. Well, what we want to do now is find that 100th term. So now I'm going to switch gears. The 100th, excuse me, class, that 100th term. So if I'm trying to find A of 100, all I have to do is plug 100 into that formula. And I will get that the 100th term is 501. Okay, let's look at our next one. Excuse me again. So, the two things we have to identify, A1 and D. So, my first term is 3. And what am I adding every time? Well, it looks like to me, I'm adding 2. So my D is going to be 2. So, when I'm using my formula, now I'm going to plug everything in. So A1 is 3. My D is 2. Now again, let's clean it up a little bit. So distribute that. So we get 3 plus 2n minus 2. So this time I get this for my explicit formula. And again, what's our goal? Well, we need to use this to find the 46th term. So that means I'm going to plug 46 into my equation. And when you do that, when you plug 46 into that equation, you should get 93. So 93 will be the 46th term in that sequence. And moving right along. So, in a sports arena, the numbers of seats in the first 13 rows in a section of the arena form an arithmetic sequence. Rows 1 and 2 are shown in the diagram below. How many seats are in that 13th row? So, let's see here. So we have in row 1, 14 seats. Then row 2, we have 16 seats. Then it keeps going and going. And it says it's an arithmetic sequence. So that means that we have that common difference. Well, we're starting with 14 seats. And that common difference to go between your terms, well, looks like to me we're adding 2 each time. So if I'm setting up my formula, I need to plug in my a to the first, and I need to plug in my d. So I'm going to distribute my d, so I have 14 plus 2n minus 2. So my explicit formula is going to be 2n plus 12. So, and what am I looking for? Well, I'm looking for row 13. So that means I need to plug 13 in for n. So 2 times 13 plus 12, that third row, or sorry, 13th row is going to have 38 seats in it. All right, so that is actually all for our notes today. So, thank you for joining me. Please make sure you have all of this written down so tomorrow we can come back and continue with our practicing.